What is latent heat of vaporization in boiling? Have you ever wondered what happens when water boils? It's not just about bubbles and steam. Let's take a closer look at the latent heat of vaporization in boiling. This concept is essential in understanding how liquids transform into gases. When a liquid reaches its boiling point, it requires a specific amount of heat energy to change into vapor. This energy is known as latent heat of vaporization. It is the heat needed to break the bonds between the molecules in the liquid. Even though heat is being added, the temperature of the liquid does not increase during this phase. Instead, the energy goes into changing the state of the liquid. For instance, when water boils at 100 degrees Celsius, it absorbs heat without getting any hotter. This is because the heat energy is used to separate the water molecules, allowing them to escape into the air as steam. This process continues until all the liquid has turned into vapor. The term latent means hidden. The energy is stored as internal energy in the vapor, even though it does not cause a temperature change that can be measured. This is why boiling water can stay at 100 degrees Celsius until it is completely evaporated. The latent heat of vaporization plays a vital role in thermodynamics and phase changes. It defines the energy required for the transition from liquid to gas under constant temperature and pressure. Water, for example, requires a significant amount of latent heat to vaporize. This is why steam can cause burns that are more severe than hot water at the same temperature. The energy released when steam condenses back into water transfers more heat than the water itself. Understanding latent heat of vaporization is not just an academic exercise. It has practical applications in designing heating and cooling systems, predicting weather patterns, and explaining natural processes like evaporation and condensation. In essence, the latent heat of vaporization during boiling is the heat energy that a liquid absorbs at its boiling point to convert into vapor without a temperature increase. This reflects the energy needed to break the bonds between molecules during this phase change. So, the next time you see water boiling, remember the hidden energy at work, transforming liquid into gas.